If you want to own a CNC mill, but don't think you can afford to buy one off the shelf, then building one might be a reasonable option. This video shows how I evaluated the alternatives and chose to build a CNC mill. This series is all about the product and technology choices I chose for my mill. It will describe the changes and directions that happened, the real costs of my choices in time and dollars, and it will go into detail, demonstrating how I built the mechanics, electronics and computer setups, enclosures, coolant delivery, work holding and tooling requirements that you will need to complete a project like this. I needed a CNC mill so I can work on components for several large projects that are currently under development. These include manufacturing blades for miniature steam turbines, small production runs for my antiquarian peripherals, cutting gears and parts for a reproduction Enigma machine, and a number of other projects. I needed something better than my existing PM25MV, which is a hobbyist grade mill. The tolerances and repeatability needed for parts like the Enigma machine rotors and steam turbine blades are really important. I could not afford even a low-end, off-the-shelf CNC mill, and low-end mills would not have had the precision I needed anyway. Marty over at Marty's CNC Garage argues that converting an existing CNC mill using modern controllers and motors is a way better option. But I didn't want to buy into potential issues with wear and refurbishment, and frankly anything I could find was either too big for my machine shop or required three-phase power. I live in downtown San Francisco, not far from Adam Savage, although he has no idea that I'm here. My shops occupy my basement, leaving very little room for new machines. I already had a Precision Matthews mill, and liked it a lot. Then Precision Matthews came out with a new mill, the PM728VT, that had a whole bunch of improvements. It was a much more massive and stable machine, groundways provided, a higher precision table with more travel. It had an integrated one-shot oiling system, it had speed control for the DC motor, and a much higher spindle speed so that I could cut aluminum. The original plan was to use high-precision ball screws, double ball nuts, Technics hybrid servos, and to do all the machining of the required adapters. While I was busy researching options, I was taking CNC courses at the local technical college. They had big Haas mills and lathes. I learned G-code and manual programming for CNC, and I developed multiple projects using several computer-aided manufacturing applications. So let's talk about the options. You could go out and buy a new machine. Brands like Haas, Seil, Tormac, and many others have a big range of prices and capabilities. But that's a lot of dollars to spend. Your machining purchase is never the end of your investment. You need to add a very large chunk of change for tooling, work holding, coolant systems, enclosures, and the list goes on. You could buy a used machine. Depending on where you live, however, there just may not be many options, and then you have to deal with wear, hardware faults, shipping costs, old controllers, and power requirements. The other option is to build a machine. You could do your own design work and build the conversion from scratch. You could also buy a full conversion kit. Spend some time doing evaluation, as some kits will require really major modifications to your mill. You could also opt for a mechanicals only kit. This is the option I eventually took after a couple of wrong turns that we'll talk about through the video series. I opted for a kit from Precision Matthews. It required no hacking of the mill and everything just fitted. There are some things to think about if you go the DIY route. The biggest value other than cost savings is that you'll understand everything about your mill and controller by the time you're done. Sourcing components like ball screws is way harder and more expensive than it looks, and I really wouldn't advise it for your first mill. The real challenges are about everything else that allows a computer to successfully drive those ball screws. This video series will walk you through the choices I made and the construction process for mechanicals, electronics and controllers, the enclosure, and much more. I owe a vast debt of gratitude to the many YouTube creators that have taken this route before me. You'll find a list of their channels in the comments section of this video. To see the various project stages of my mill conversion, please subscribe to this channel and hit the like and notify buttons. This project was a challenging and fun ride, and I hope you will join me to see how it all came together.